Hello guys, welcome to my channel. This is Ehsan, and in today's video I'm going to provide you a solution for the previous video about LT3088. This is a linear regulator. In this playlist I'm going to give you a mindset for how to become an electrical engineer, and you're going to look at through the data sheet for some kind of questions that I provided for you guys and find the answers. And this is important to find the key points for the design. And in today's video I'm going to give you a solution for that problem. Okay, but if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. This is the document that I provided for you, but this is actually the solution for that document. I told you already to look through the data sheet for this device, and here are some questions. What is the input voltage range of this regulator? You're supposed to find out these really important numbers in the data sheet. This is really important to looking for the input range of this device, which is 1.2 to 36 volt, the output range, the maximum current that this device provide, or the set pin current. What is the set pin current? But the important question, and these are different packages of this IC. Be careful when you want to buy one of these. Be careful about the packages, about the sizing, about how many ports. For example, this one is a 8 pins on the sides, and in this one under the device, this has just 4 pins. This has just 3 pins. So be careful about the different packages, different footprints when you want to create them on the schematic and the footprint of in Altium. So when you want to order one of these, be careful about the part number relating to these ones, and these are the temperature ranges. Okay, so be careful with them. And and these questions about relating C set and C out. Why use these ones? And C out is for the rejecting the ripple at the output, and C set, one of the applications of using C set is that it's because they want to soft start the device, and this is something that we're going to looking at it on the LTspice today. And another application is that since the C set pin is a high impedance node, unwanted signals may couple into the set pin and cause erratic behavior. The easiest way to remedy this is to bypass the C set pin in a small amount of capacitance from set to ground. 10 pico to 20 picofarad is sufficient. Okay, and here this is question 9. Maybe this one is the most challenging ones, and it's involves design. Okay, if R set equals to 30.1 kilo ohm, calculate the output voltage, and if C set equals to 100 nanofarad is added in parallel with R set, determine the time required for the output to stabilize and verify the result using an LTspice simulation. First, I do some hand calculations because the current set is 50 microamp, so V out is calculated in this way. So we estimate the output voltage is 1.5 volt, and adding this, let me just run the simulation. This is the LTspice. This is LTspice, and again I mentioned that you can see these files in my GitHub repository. I put the link in the description. Okay, all of these files, the PDF file, the simulation file. Okay, this is LT3088. This is input node, set node, output, and this is R1, which is 30.1 kilo. So first I remove this 1 nanofarad, just remove it and run the simulation and see the result. this is output, this is input, this is our input, and this is our output. Okay, you see input 5 volt and output almost 1.5 volt. And if I zoom in, you can see that V out after maybe 21 microsecond stabilizes into 1.5 volt. You can hit C to see these values. Okay, 1.5 volt after almost 19 microseconds. This is a really small amount. Now I added this 100. You can hit a space to fit this in this circuit in LTspice. So I connected this 100 nanofarad in parallel with R1 and see the result. And before that, I want you to get the mindset for this design. You see, there is a delay when I add this 100 nanofarad, and the output stabilizes after 5 times R set times C set. So 5 times 30.1 kilo ohm times 100 nanofarad, almost 15 milliseconds. Now I'm going to show you in the result. Okay, so run the simulation, and now look at the result. If I zoom in, you can see that maybe it's better to zoom in there. Okay, now I hit C to see the result. You see, after almost 15 milliseconds, which is I calculated already, you can see after 15 milliseconds the output reaches to the point almost 1.49 volt in the output. This is how you can verify the result that I gave you the problem relating to this. This is really important for you to familiarize yourself. On the one hand, handy calculation for this design and the simulation. Verify your result in the simulation. And if there is a difference, try to understand why there is a difference. Okay, and then after that, the final result is in the implementation. And if there is something problem in the implementation, you can go through it easily because you already have the mindset in the hand calculation and in the simulation results. So be careful with these points. This is really important. Okay guys, this is the end of this video, and I will see you on the next video. I hope you like it. If that's the case, please give me a thumbs up, and thanks for watching.